got to give the people. Get the people what they want. Yup, that's right. It's the remix, baby. Mr. Bass, I'm here. Let me quit wasting your time. All right. Let's talk about... No, let's not do that. Let's talk about completing the square to find vertex form. So first we got to talk about completing the square. What in the heck is completing the square? I know you've seen this, but I want to make sure you know why it actually makes sense. So x plus 6 times x plus 6 is called a perfect square because literally x plus 6 times x plus 6, both sides are the same, which means all four sides are the same, which means that shape would be a square. And we know it makes x squared, 6x, 6x, and 36. So x plus 6 times x plus 6 squared. That is a perfect square, and that equals x squared plus 12x plus 36. This is all building from the area model. This is all stuff that you know, so you're just going to get it down. And again, this is called a perfect square because both sides are the same. Just like if I drew a regular picture of a square, if this side is 4 and this side is 4, that means this whole thing is a perfect square. So go ahead and get that down. Now, there are some connections that we have to make between the standard form and the factored form of a perfect square. So what are the connections that we have to make? So first, we're going to take this same example. The standard form of this would have been x squared plus 12x plus 36. We've been working with stuff like that. The factored form of the same thing is x plus 6 squared. So there are a couple of things that I have to notice. First one, if I cut the middle term in half of that standard form, I will get the number that's inside the parentheses. So look here, if I take this middle term, which was 12x, if I take that and I cut it in half, 12 divided by 2, I end up with 6. And 6 is exactly the term that is inside the, and that is hecka ugly, that is inside the parentheses, all right? So you see that that is always going to be true. The other thing that's going to be true, number 2, is if I square the half of that middle term, I'm going to get the third term. So let's go back here. That middle term, I cut it in half and I got 6. Well, if I take 6 and square it, I get 36, which is my third term. Those two pieces will always happen. They will always be true if you have a perfect square. And we're going to use those pieces and a little tricky algebra to do a process that is called completing the square. All right, so to convert a quadratic from standard form to vertex form, I will use the characteristics we just learned to complete the square. And in this video, we're just going to do one. We'll be working on it in class plenty, but we're going to see one in the video. I wanted to give you all the background. So go ahead and write down this example. X squared minus 6x minus 19 equals y. That's my equation. All right? So I'm going to do some manipulation with this. So first of all, this equation, you don't have to write that part. This is not factorable, okay? I can't like break it down like this and factor it. It doesn't work. So I'm going to do a thing that's called completing the square. I'm going to say, you know what? I want to group just these two pieces together. All right? And then I'm going to do some nice stuff with it. So when I group, now I'm basically saying I'm taking x squared minus 6x plus something minus 19. Okay? And I'm setting that equal to y. And what I'm going to do is for this something that I don't have yet, I'm going to set it up so that this whole thing becomes a perfect square. So what am I going to do? I'm going to use those two rules. The first rule says we'll take this middle term and cut it in half. All right, cool. So I'm going to take negative 6 and divide it by 2. I end up with negative 3, okay? So what do I know about this number if I was making a perfect square? You should remember that that was going to be the number that's inside the parentheses of the perfect square. Then with that number, negative 3, I'm going to square it. And that is 9. And if you remember, 9 is the third term of the perfect square. So I'm going to take 9 and put it right here. Again, I just made this up out the blue. So you're like, Bass, that ain't legal. Well, yeah, it is legal if I decide to add 9 right in here. I'm going to go ahead and subtract it as well. So really, I just added 0. If I add 9 in here, but then I take 9 away, I didn't actually add anything. So I can do that as much as I want. I said, oh, I'm going to add 9 to this equation, but then I'm going to take 9 away a little later on. Okay? So that's totally legal. So what did I do? This now, x squared minus 6x plus 9, just this part of it is a perfect square. If I factor this thing, boom, 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 and you're going to do this, x squared, 9, blank plus blank equals negative 6, and blank times blank equals 9, you're going to figure out that, oh, that's negative 3 and negative 3. X minus 3 minus 3. Oh, look, that's this number right over here that we just did, right? This is the perfect square that we just created. So I'm noticing that, oh, well, now I've created this perfect square, so this actually means x minus 3 squared. And again, we see it right over here. So this is x minus 3 squared minus 19 minus 9 equals, not 0, equals y. Okay, well, let me start simplifying this more. X minus 3 squared. Well, what is negative 19 minus 9? That's negative 28 equals y. Well, how have you all seen it more? You really see it, y equals x minus 3 squared minus 28. And now you should be like, oh, snap. This looks like those function transformations. Oh, this is a quadratic. It makes a parabola. Oh, this one tells me it needs to move, what is that, negative, so it needs to move right 3 spaces. Oh, this one's telling me it needs to go down 3 spaces. These 2 points are the vertex. That's why this is called vertex form. So, if I have y equals x minus 3 squared minus 28, the vertex sits at 3, negative 28. Remember, when it says minus 3, I always do the opposite of that, so it's 3. And this tells me go down 28, negative 28. That's where my vertex is. This is my vertex form. That was my one example. That was my entire video that went through the whole process. Thank you all for doing your homework. I'm going to see you tomorrow. I'm out.